Okay. So at least for the beginning, please show all this. Show me. Okay. Show me you're multiplying the 18 times r like this. Okay. And then the 2 times 10. Alright, get 20. And then you have to solve, right? And let's go here. How would you, person's name on the screen, how would you solve this? What would be the next step?
Would you basically divide anything?
Alright.
I can say the fraction again.
Alright. And next person. Right here. What does this reduce to? Eyes up front. What is it reduced to? No, that's a decimal. What is it reduced to? So if you divide top and bottom by, well, not 10, but 2, you get 10 over 9. Notice how I want you to leave it as a fraction. So a calculator is not an excuse to just make everything decimals from now on. It can help you. Some of the calculators actually reduce a fraction for you, but it's don't want to go straight to that. But just in case, what is the decimal here?
1.9.
The decimal.
1.1.
Yeah, see the 1.11111, that's why we want to know how to use fractions and not just round it. If we use a decimal, it's a rounded number. So a rule is that if there's ever anything repeating, you leave it as a fraction. You don't want to write 1.1 repeating. Surely. Alright, let's try another. Now you can see that there's a negative here. Go ahead and do this. Write down what I did. So put the negative. Put the negative on the top. And then when we solve this, same thing. 16 times x equals -6 times 14. Okay, what is 6 times 14? Okay, so we get 84, right? Negative. Divide both sides by 16. I think, what, 4 goes in the top and bottom? How many times does 4 go into 84? 5 times 4 going to 84? Punch it in.
21.
21, so we have, is this right? 21 over,
Oh, negative.
yeah, negative 21. Good.
Just a second. My calculator made
So you can see why we're doing the warm-up of fractions. We need to be top at those in order to do these correct. So nice fraction answer. You can use a calculator to multiply these. You can use a calculator to reduce them, but it doesn't mean just put a decimal. Okay, you need to put it as a fraction. Let's see here. Anything else? Do we want to do more, or do we think you just want to work? How about this? Let's go ahead and have you guys do 3. 6. 3 is actually easy. Actually, let's go through 4 together. I want to show you remind you of the shortcut we did yesterday. So first step on 4 is noticing that this is a negative down here. Let's move that negative to the top. Make it a negative 16x. So I have 15 times 18. And I have 16x negative times 8, and those are equal to one another. Now, these numbers can get big like this. And if we do 15 times 8 and 16 times 8, you're going to have some big numbers that you're going to have to figure out how to reduce. So I mentioned this yesterday. You can go ahead and divide by both sides by something that goes into some number on both sides. So like here, what number would go into something on both the left and the right? There's just one number that would go into both sides. There's 2, right? 2 would go into 8, and 2 would go into 18. So divide both sides by 2, right? And 2 goes into 8 how many times? 4. And then on the right-hand side, how many times does 2 go into 18? 9. Now, is there anything else that goes on the left side? We have negative 16 and 4, and on the right side we have 15 and 9. Is there anything that goes into both sides? Any one number that goes into both sides?
1.
Besides 1, we're reducing. Then once you come to that place, like 2 doesn't go into 15 or 9. 3 doesn't go into 16 or 4. So there's nothing that goes into both of them. This is kind of like reducing, but you're not multiplying everything together first. You're reducing before you multiply it together. So left over is going to be negative 16x times 4. What's 16 times 4? Punch it in. Yep.
64.
64. Negative. And 15 times 9.
435.
435?
135.
135. That sounds better. All right. Yep.
But I know you can't multiply a letter.
Multiply a letter and a number?
Like, negative 16x
Mhm.
times 4. I
Yeah.
thought you said do that.
You can't add them. You can multiply them.
Oh,
So like something like this, like 2x plus 2, that cannot be simplified. But 2x times 2 is 4x. So yeah, if this was addition, we would not be doing this. Now divide both sides by the negative 64. Now here's the nice thing. Since I already kind of crossed out what went into both sides, I already know that this is the fully reduced answer. I don't have to mess with it. I don't have to say, well, that's a really big number. I wonder if it reduces. How do I reduce that? If you do it ahead of time, when it's just like 8 and 18, and you find out, well, nothing goes into the left side that goes into the right side, at the end here, you're done. You never have to worry about reducing. So it's a good method to think about and to try to use. Because you guys could probably easily figure out what goes into 18 and 8, but what goes into, this would have been something twice as big, would have been much harder. It would have been like 270 over 128 you'd have to try to reduce, and that's not a good time. Okay. Yep. Let's see here. I think so. So let's have you guys work on the front. When you get to the back, you're going to see a slight variation, and we'll go ahead and go over that in a little while. I want to have you guys just work on the front and see what you get, see how we're doing. Okay, so when you get to the back, it just looks a little different, but we have some addition or subtraction on one of the parts. You guys know that 1 is the same as 1 over 1, right? So we can still set it up and do the same process. And well, this, we have 1 times negative 1 plus a equals just 1 times 9. And with the 1s, it doesn't really change it a whole lot. 1 times anything is that anything. 1 times 1, 1 times 9, and now we'll have to add subtract to the thing. Write this down, have it written down, so when we come back on Monday, we'll have an example. Alright. Let's skip down a few. Go to like number 15, I think. Okay. How about 17? Let's do 17. So we got 2 times 12 plus x, and x times 9. So I put 9x, don't put x9, but 9x. Now, what did I leave off? What's missing here that I did on the first one? You look back. What did I leave off? Parentheses. Yeah, you gotta have parentheses, because we have to multiply 2 times everything on the top, not just the 12, but everything. So you gotta have parentheses. So we got 2 times 12, which is 24. 2 times x, that equals 9x. We get the variables the same side. Subtract 2x on both sides, right? So 24 bring down equals bring down 9x minus 2x, 7x. And you can see on purpose, a lot of these answers do not have nice whole integer number answers. Okay, we're leaving as fractions so you guys get a lot of practice. You got to know how to reduce them. You got to know if they don't reduce, like does 24 over 7 reduce at all? No, so you just leave it as, yeah, 7's cancel out, so x equals 27. Notice how I lined everything up, like the equal signs stay in order. All the x's are vertical. Like, try to keep it neat and as lined up as possible. Okay? And of course at the end, a box or circle your answer so it's obvious. No decimals, no mixed numbers. Okay, this is the final answer. This is the way you want to put it down. Okay, but that's the back. We'll do a lot more of these together next week. Focus on finishing the front for sure. If you want to try the back over the weekend, that's fine. We'll keep on working. We still got a good 5 more minutes. Keep on working.